going to take a look at the Precious Metal Verifier PRO from Sigma Metalytics. The original PMV was released in 2014 following the explosion of high-quality counterfeit coins and bullion coming out of China. It was the first tool of its kind measuring the resistivity of the metal and comparing it to a database of empirical values. The interface displays a set of brackets that represent an expected value range for a given metal and illustrates the test result as a block that falls somewhere on that scale. Items that are not made of the expected metal typically fall somewhere outside of that scale. It has become quite popular among coin dealers, pawn shops, and collectors, and does a good job identifying most common fakes. But it does have some limitations, and it needs to be used in conjunction with other simple tests, such as checking the size and weight of the item. Sigma has built upon this testing technology, developing this new Precious Metal Verifier PRO. This device takes the resistivity testing to a new level by measuring both the surface resistivity and the resistivity all the way through the item, and combines that with dimensional measurements to check the density of the item against known values. The idea here is that a counterfeit item could potentially match the resistivity of a precious metal or the density of a precious metal, but not both. If we look at a table of the resistivities of metals, we see that silver is the least resistive metal, followed very closely by copper, and then a little more distantly by gold. So we can run into trouble if we check only the resistivity value without any other evaluation. Pure copper can just about match the resistivity of silver, and copper or silver alloyed with a little bit of a more resistive metal like zinc can match the resistivity of gold. However, these cheaper metals are less dense than silver and gold, so counterfeits that match these electrical properties will either be less than the advertised weight or larger than the genuine article. And on the other side, a counterfeit could match the dimensions and weight of a genuine piece by using one of only a few metals that have a similar density, such as tungsten, but the resistivity of those metals is significantly higher than silver or gold and would fail the PMV testing. So at this time, there is no known way a fake that is made of something other than gold or silver could pass both of these tests. So let's take a look at the device now. The PMV PRO comes in a nice hard shell case with custom foam cushioning. There's room to store the charger and the optional wands on the side. Much like the original PMV, there are optional wands available for the PMV PRO. There's a micro wand which can measure the surface resistivity of items as small as 3 millimeters in size, and there is a refiner's wand for items that are at least 14 millimeters thick, and this wand measures 50% deeper into the metal than the optional bullion wand that is available for the original PMV. Couple things to note up front. The PMV PRO I have here is a pre-production model. I have been working with it for a while and providing some feedback to Sigma. There are a few differences between this unit and the final product that we'll be shipping to customers. This prototype has some 3D printed components, including the bridges up here for the main sensors, and these will be injection molded plastic parts on the finished product. The molds just weren't ready when they put these demonstration units together. There are also a few typos in the menus and an issue with calibrating the wands, and they've dialed in some of the ranges since I received this unit. All of that has been fixed in the next version of the database, which will be on the production units. And in shipping one of these back and forth across the country, we discovered there was an internal component that had a tendency to shake loose, and Sigma has addressed that by adding some internal bracing. So it's been nice working with the guys at Sigma on this. They've been very open to feedback during the development process, and they've really addressed all of my concerns in the finished product. So the basic functionality of the machine, you have two main sensors, a large sensor on the left for items 30 millimeters and up to 14 millimeters thick, and a small sensor on the right for items 8 millimeters and larger, up to about 4 millimeters thick. And each of these actually has two sensors, one inside the main body of the device and one in the bridge. And together, these measure the surface resistivity, the resistivity all the way through the metal, and the thickness of the metal. And these can measure through plastic cards and capsules and slabs, and this is really key, especially measuring the thickness, to being able to thoroughly evaluate a lot of different items without cracking open the packaging. Down here is a color display that shows the results, as well as displays all of the menus and options, and it's also your measuring device to check the length and the width, or the diameter of the item, to verify the density. A printed manual is included that goes over the usage, and Sigma has a nice series of videos describing how to navigate the menus, so I won't repeat all of that here. If you've used the original PMV, it'll seem pretty familiar, and if not, it's still easy to pick up. So let's set this for pure silver and take a look at a couple of items. We'll start with a series of Silvertown bars. I already know from prior testing that one of these is real and the other two are counterfeit, so let's see if the PMV Pro gives us the same results. We start by setting the metal to pure silver and the weight to 1 troy ounce. Since these bare bars are thin enough to fit under the small sensor and not quite wide enough to cover the positioning circle under the large sensor, I'll use the small sensor here. If we take a look at the screen, we'll see 2 data points. The top bar shows us the surface resistivity reading, which is what the original PMV measures, and the bottom bar shows the resistivity all the way through the bar, which is one of the new features of the PMV Pro. If the item is a pure metal without any plating or filler, both readings should have a very similar numerical value. In this case, we get 2 right arrows telling us the resistivity values are much higher than what is expected for silver, so this particular bar is a fake. The second bar gives us similar results. The surface and through values are different enough to raise suspicion, and both fall far outside of the acceptable range. The final bar gives us results that both fall into the yellow zone, which tells us these numbers can be expected of pure silver, but to use caution. So we'll go ahead and use the other new feature of the PMV Pro and check the dimensions. We already entered the weight, the PMV knows the density of pure silver, and we can see on the screen that it has already measured the thickness using those dual sensors. Now we'll push the measure button, choose the rectangular shape, and the PMV Pro will show us which measurement reference line to use. We'll line our sample up with the horizontal line and the first vertical line, and then use the arrow keys to adjust the bottom horizontal line to match the edge of the bar. Now we can see that the left side of this bar falls within the green range, which represents the expected size for pure silver. Now this bar has passed both the resistivity test and the size test, so we can be reasonably confident that this bar is real. I'll go back to the previous bar for a moment just to demonstrate what a counterfeit bar looks like in the size test. I'll go back to the main screen and place one of the counterfeit bars back under the sensor to get a thickness measurement. This counterfeit is made of silver-plated brass. Brass is significantly less dense than silver, so when we adjust the bottom horizontal line, we'll see that this bar is significantly larger than would be expected for pure silver. Now we'll take a quick look at a few silver rounds. This silver eagle falls in the yellow zone with nearly identical surface and through values for resistivity, and with the weight set to 1 troy ounce, the diameter falls right in the middle of the green zone, validating this coin as silver. The second piece falls far outside the acceptable resistivity values and is clearly not made of pure silver. And finally, we can examine a copper round, which we saw earlier can fall inside the brackets for silver on the original PMV. On the PMV Pro, the copper round results in resistivity values almost identical to those of the silver eagle. However, with the Pro, we can set the weight to 1 standard ounce using the custom weight input and check the diameter of the round. This round falls outside of the acceptable size range for silver. So by evaluating the density of the metal this way, the PMV Pro could indeed detect a silver-plated copper counterfeit, which is a nice improvement over the original PMV. Let's test another item that can be problematic on the original PMV. Some counterfeit gold bars are being produced with a copper alloy that matches the resistivity of gold. This can result in a counterfeit bar that reads as real gold on the PMV. One of these 5-gram gold bars is real and the other is fake. However, we see that both result in readings inside the brackets on the original PMV. On the PMV Pro, the first bar gives us both surface and through values in the green, and the size of the bar is also validated. On the second bar, we see that the through resistivity value is slightly into the red zone, and the bar is significantly larger than the acceptable size. So here too, the PMV Pro excels beyond the capabilities of the original PMV and is able to distinguish the genuine and counterfeit bars. It is important to note that the small sensor is limited to testing items about 4 millimeters thick, so not all packaged items will fit. So far, it appears that for bars 20 grams and smaller in plastic cards, the only genuine bar that does not fit is the Perth Mint 20-gram bar. Numerous counterfeit bars 20 grams and smaller in plastic cards are too thick to fit under the small sensor, so that in itself can be a red flag. For these items, it is best to remove them from the packaging to test. The large sensor can accommodate many 10-ounce silver bars, which can also be checked dimensionally. When using either of the available wands on the PMV Pro, you get a surface resistivity value only, similar to the original PMV, but with a little more feedback thanks to the color display and numerical value. The through value and the thickness measurement are only possible with the main bridge sensors. The wands are useful for thicker poured bars and for items too small for the main small sensor. Overall, the PMV Pro is a worthwhile upgrade from the original PMV. The new thickness and dimensioning capability allows the PMV Pro to distinguish copper from silver and copper alloys from gold, addressing two of the largest limitations of the original PMV. A PMV Pro with the optional wands, coupled with a basic pocket scale to confirm weights, is capable of testing just about any bullion item on the market. And with a price tag 7 to 10 times less than that of an XRF device, the PMV Pro is likely to become a favorite among industry professionals and serious collectors.